So these are our notes for density. Density is something that you'll go over a lot more in chemistry, but it's something that we need to understand because we have a volume measurement, we have a mass measurement, we have a measurement for length and width, but we need to have something for the compactness of whatever our molecules are. So it's telling us if something can float or not. So if we look at our mass and weight, or mass versus weight, mass is going to be measured in grams. So measured in grams, mass is the amount of matter in an object. So the amount of matter in an object. And weight depends on the attraction of gravity. And on Earth, your mass and weight are going to be the same, but other places in the galaxy it's going to be different because gravity changes based on what you have. Just like when you see astronauts floating in space, gravity is going to change based on where they are located in space. Now, when we look at volume, volume is going to be measured in milliliters or centimeters cubed because it's length times width times height. So, or milliliters or liters. So the amount of space an object takes up. So like I said last week, an object takes up. So like I said last week, we have length times width times height means that we have a three-dimensional object. That means that we are seeing how much total space can be taken up in this room, whether that be your length times width times height, or to find it based on packing the room as full of air as possible. So when we find volume, it's measured by length times width times height. We can find it based on the different objects we have. So spheres are going to be measured differently than cubes, cylinders are going to be measured differently than rectangular prisms, and so on. As we go into density, though, density is the amount of mass in a given volume. So amount of mass in a given volume. So this means basically the compactness of an object. That's where our mathematical definition comes from. So if we look at density, if we look at our pyramid up here, which is how I'm going to basically teach you how to do it, is going to be equal to mass, or grams, divided by volume, or centimeters cubed, or milliliters, either one. And that's what we have there. So density is just another measurement, like we've been measuring before. So when we look at it, our particle definition basically states that how tightly packed we are. How tightly packed we are. Packed or spaced matter is. So density is based on how tightly packed something is. So based on the definition, the fact that water is a liquid and has a density of 1 gram per milliliter, we know that any substance that has a greater density than this, so anything greater than 1.0 is going to sink. Anything lower, so like 0.9 and below, is going to float. It's why ice floats, because technically ice is less compact than what water is. Density is a physical property. So we talk about different kinds of properties. We're talking about how it can identify what a specific substance is. Now, it will change only physically. It will never change. Once it changes chemically, then it is a new substance. Now, with our practice problem, so a piece of metal with a mass of 1.58 grams is placed in a graduated cylinder and filled with 25.65 milliliters of water, and it rose to this many milliliters. So we know one way of finding it is to place it into a graduated cylinder, see how much it raises. I know you guys said that you have done that before. So if we take our 25.87 and subtract our 25.65, we get our 0.22 milliliters. And remember, density, so since we're looking for density equals mass times or divided by volume. So if we do this, we're going to put our mass here, which is 1.58 grams. We're going to put our volume here, which is 0.22 milliliters. And all we have to do is divide. So we take our calculator, 1.58 divided by 0.22 gives us an answer of a density of 7.18 grams per milliliter. So based on that, would it float? Our answer is probably not. So 7.8, 7.18, 7.2. If we look at that, that's somewhere around the density of heavier than copper, or around copper, so probably around zinc when we're looking at that. These notes do go with your attached, whatchamacallit, I'm trying to think, slides presentation. So if you would like to do it with that, you are more than welcome to do that as well. This is just our video doing it together. So density, substance. So we have a density of 4.5. So we know density goes here. So we have 4.5 grams per centimeter cubed. And we know that it has a mass. What is the mass of a substance? When we have a volume of 6.00 centimeters cubed. Now we're looking for the mass. So in this case, when we're looking for the mass, we multiply these two because they're on the same level. Remember that rule that I was talking about with dimensional analysis? If they're on the same level in the pyramid, the same thing applies. So in this case, we're taking 4.5 and multiplying, so we can call it multiply 6.00, and we get an answer of 27 grams. So this particular substance is going to be 27 grams. And let's do one more. So a substance has a density. So in this case, we'll have to create our own pyramid or triangle, however you want to call it. It has a density of 5.38 grams per centimeters cubed. Grams per centimeters cubed. Make it look small. I wrote it too small. And we have a mass because we're looking for a volume. So we have a mass of 2.33 grams. So in this case, we're going to do the same thing. We're going to divide our mass by our density to get our answer. So we're going to take our 2.33, divide it by our 5.38, and our answer is going to be 0.43 centimeters cubed for our volume. And that's how simple it is. You can do your assignment, and that is all for today. Good luck, and our quiz is going to be on Friday.